Hello, Assalamualaikum. Hey guys, today I'm going to do a tutorial on how to write the electronic configuration of an element using the spdf notation. Okay, so we have here an element of vanadium with a proton number of 23. So first thing first, whatever I like to do when writing electronic configuration, I need to determine how many number of electrons are there in vanadium. So in the neutral state, the proton number is equal to the number of electrons. So that means vanadium with the proton number of 23 would have 23 electrons. Okay, so how are we going to arrange 23 electrons in the spdf notation? This is where you have to apply the three sets of rules, and one of it would be the Aufbau principle. Okay, as for starters, since this spdf notation is quite new for you guys, I would recommend you to write the Aufbau principle ascending order, in which it states that the electron will fill in the lowest energy orbital first and then the other energy orbital in order of ascending order. So since it's quite new, in order to get used to it, try get used to it of drawing this, and then just go across the order in terms of the way that it's been written. So now we're going to start writing the electronic configuration in accordance to the Aufbau principle. Now another thing that you should note that s orbital can occupy a maximum of 2 electrons, p orbital can occupy 6 electrons, and d orbital can occupy about 10 electrons. Okay, in accordance to the possible orbitals that are available in the subshell. Okay, another thing that you should note as well is that the reason why we have to note 23 electrons, we have to know how many electrons are there in the element, because in order to write the electronic configuration, we have to be able to acknowledge how many elements are there in order to arrange them in the spdf notation. Okay, so we have 23 electrons, so let's arrange them in an electronic configuration using spdf notation. So follow the order 1s2, okay, 1s2, and then you follow with 2s2, 2s2, and then 2p, 3s, 2p6, 3s2, and then 3p, 3p6. Okay, alright, you can stop there and then calculate how many electrons that you have already distributed, and then minus it with the electrons, and so that you know how many remaining electrons are there. So you would have about, so there's 4, 6, there's 18 electrons. So you basically have 23 minus 18, you would get about 5. You have 5 more electrons to fill in. Okay, so you have 5 more electrons to fill in. So in the previous video that I've said before, that in terms of the 4s and the 3d, oops, I did not write 3d here, 4s and the 3d, so since our principle said that the electron will fill in the lowest energy orbital and then proceed to the next, because we have to arrange it in the, so we have to put the electrons in the 4s first, then the 3d, because the 4s, we have to let the electrons occupy the 4s, because the 4s have a lower energy orbital than the 3d. Okay, so 4s2, and then left 3 remaining will go into the d orbital, 3d3. Okay, so calculate back the total, you calculate back the total of electron and see you have 23 electrons. So this would be the electronic configuration of vanadium. Okay, and then if you have a monoatomic ion, for example the question B here, it says vanadium 5+. So basically when it says vanadium 5+ and it becomes a vanadium ion, so it has lost 5 electrons, because if it's a positive charge it loses electron, that's why 5 electron has been lost. So it's the same concept that we've learned before. The electrons will lose electron in the outermost shell. So what it will lose is that it will lose the outermost shell, which is, if this is the ground state, the neutral state of vanadium, electronic configuration. So losing 5 electrons means losing the outermost shell, which is this part. This is the outermost shell for S2 3D3. If you total it becomes 5 electrons. So vanadium 5 plus would basically mean they would have 18 electrons. So 1s2, 2s2, 2p6, 3s2, 3p6, and that's it. Okay, because vanadium had already lost 5 electrons in order to achieve the octet electronic configuration. So this is vanadium ion electronic configuration in terms of SPDF notation. Alright, so I hope this video is useful for you guys. Do attempt the tutorial question, and if you have further questions, you can always ask your lecturer. Bye!